Okay, so question 3, page 43. That one's a tricky question. There's actually no math to do on this one. It's a tricky question. Let me just check at the back, make sure I got it. 1.63. Yeah. The acceleration remains the same for all three answers. And why is that? Well, if you have a, let me just draw this here. If you have a ball, right, that you throw in the air, the acceleration due to gravity, g, right, it's 9.8 meters per second square, and it's down. That never changes. What's going to happen is it simply doesn't change. And so it's a uniform acceleration. So if you look at the graph of acceleration, I'll try to do it here. And small. So uniform acceleration, it's constantly the same. And so it doesn't matter in terms of its velocity. I don't have the space here to draw the displacement, but if you throw something in the air, the displacement of this, if I draw displacement here, it's going to be a parabola, right? So that would be height. We'll just say it in right? In meters. We should put it bracket meters here. And so as time goes, this ball is just going to go and then hit a peak and then to start fall back as time goes. Just picture yourself throwing a ball up. And so this here, there is still an acceleration, although you have a slope of 0. So this here, it means it will cross the x-axis of the velocity graph at times, call it TP for T peak. So it's a positive slope, right? So it means that the graph will look like this for velocity. Okay? Slope positive for every point, positive. If you look here, the slope here from here to here, this is all positive slope. Do you agree? Sorry, this is all positive. Imagine the slices here as your tangents. So, right. I should have put this as negative. Right, because now it doesn't work. Because this is up. Oh, yeah. Well, so let me just redraw this. Let me get a new one. Let's start this fresh. Okay. So, sorry, because I changed my up and down. So displacement, this time. Acceleration. Okay. Right. Okay, so here, let's then keep everything up, and then that will make more sense now. So if I put everything as facing up, right? So here we'll put it as up. velocity up, displacement is up. Okay, so now it's going to make a bit more sense. Like this. This is at T peak at a certain height. Okay, so if you look here, positive slope, negative slope. This is a really bad parabola. So at T P here, right, positive, negative. So my slope is falling down. Right, so now my slope is all negative, and that fits with our drawing. Our acceleration is going to be somewhere in the negatives. And then if we did the math correctly, our measurements correctly, we should land on exactly 9.8 meters per second squared. So the acceleration is constant, although it moves up and down, and although its velocity, it's really high at the start, going up, because there's a high change of displacement per time, and then it reaches a peak here. It starts falling down, but acceleration remains negative. So that's number 3.